How to do Lewis dot structures by Caitlin Coons and Nick Delbrand. So the first thing we're going to go over are the Lewis dot structures rules, and then we'll incorporate them into a problem. So the first rule is determine the arrangement of atoms within a molecule. The second rule, calculate the total number of electrons in the molecule. Rule 3, place one pair of electrons between each pair of bonded atoms to form a single bond. Rule 4, use any remaining pairs as lone pairs around each terminal atom except for hydrogen, so that each terminal atom is surrounded by 8 electrons. Rule 5. If the central atom has fewer than 8 electrons at this point, change one or more of the lower pairs on the terminal atom into a bonding pair between the central and terminal atom to form a multiple bond. So, to start off, we are going to do ammonium. And as you can see, we have ammonium over here. I wrote out this, and we'll get to that right about now. So we're going to use Rule 2, and we're going to calculate the number of electrons in the molecule. So we see that there's only one N, so you're just going to use whatever group it's in on the periodic table, which is group 5. So therefore, it is going to have 5 valence electrons. And we can write it like this. And now for the hydrogen atom, we all know that it only has 1 valence electron, but since there are 3 that are going to be bonding to the nitrogen atom, you have to multiply the number of valence electrons by 3, so that will give us 3 valence electrons. Alright, so now we know that there are 5 valence electrons around nitrogen, and there are a total of 3 valence electrons that we need to bond to the nitrogen. So what we are going to do first is total them. Get a total of 8 valence electrons, and then if you divide that by 2 you get 4, and that's going to be your electron pairs. So I'll write it like alright. So now we're going to go to nitrogen, and we're going to start by going counterclockwise around the atom. So since there are 5, you have 1, 2, 3, 4, and then you come back up here. 5. Now we are going to bond the hydrogen atoms around the outside. So we're going to put a hydrogen atom over here, hydrogen atom down here, and hydrogen atom down here. And now since they all have 1, they're going to make pairs really nicely, like this. So now you can tell that this H is bonded here, this H is bonded here, and this H is bonded here. And then you can see that you have a total of 8 valence electrons, so it's as stable as it's going to get. And that is the Lewis stock structure for ammonium. Now we are going to move on to another one. So we are going to do aluminum bromide, AlBr3. And again, we're going to follow our rules that we set up. Al is in group 3, so it has 3 valence electrons. Alright, and bromide is in group 7, and since we have 3 of them, you have to multiply it by 3, which gives us 21.
Yes, you can. It's only $79.
What? That can't be right. That's less than I paid for these jeans.
Then you're going to do out your total, which will be 24.
That's less than I spent on your birthday present.
And then you'll do out your pairs, which will be 12.
I read a lot.
Alright, so we have aluminum in the middle for this one. The reason is that aluminum only has 3 valence electrons around the outside. And we're actually going to draw it down here to make it a little more easier. Has only 3 around the outside, so you're going to have 1, 2, 3. So now all you're going to do is you're going to take your bromide and you're going to add the bromide over here. Bromide up here. The bromide over here. Alright. So, now that we have bromide and it's 7, you're going to go around and it's going to be 1, 2, now it's bonded to the aluminum, 3, 4, there's 5, there's 6, and there's 7, which fills in nicely. And you're going to do the same over here. Doing the same thing, making sure everything is balanced out. And that is the Lewis stock structure for aluminum bromide, as you can see. One quick note that I forgot to mention in the first one is that in ammonium you have these pairs right here, which are left unbonded, and that makes them a lone pair. Just a little side note for you guys to understand. And those are the 2 for ammonium and aluminum bromide. Now I'll pass it over to Caitlin.
Alright, so the first one we're going to do is carbon dioxide. So you see I already have set up for the valence electrons, the carbon, the oxygen, and like Nick said before, if you go up to the periodic table to find the C, it's under group 4, so it would have 4 valence electrons. And if you go to the oxygen, it's in the 6th group, which would make it have 6 valence electrons. You have to multiply the oxygen by 2 because there are 2 of them. So let's write that in. What is it? 4 and then 6 times 2. 12. Okay, so then you add them together and you get 16 valence electrons. And to get to the pairs, you would divide it by 2 and you'd get 8 of them. So now let's start making the Lewis dot structure for carbon dioxide. So to follow the rules, rule 1, you have to arrange the atoms. So you would put C in the middle, and then you put the oxygen on the outside. And then we already did rule 2, we calculated it out. And rule 3, we have to place the pairs between the combining atoms. Okay, like that. So this is a single bond. You can either do it that way or in a straight line, whatever you prefer. And then we will fill in the rest of the remaining pairs. So we got, we'll put a pair right there, pair right there, pair right there, and then we'll do the same for the other side. So these ones that I'm putting in are called lone pairs. Okay, so now we have that, and that is rule 4. Now rule 5 says that if you have valence electrons that are fewer than 8, you can combine them to make triple or double bonds. So we can make carbon dioxide into a double bond. So to do that, we're going to pull down these 2 lone pairs and bring them down to make these double bonds. So I'll rewrite that for you. So we'll do them right here. So here's the 2 lone pairs left over. And here's the lone pairs that we're bringing down to make a double bond. Just same for the other side. Okay. And here is your Lewis dot structure for carbon dioxide. So next, I have another one, a little bit trickier one. We're going to be doing ethanol. And again, we're going to figure out the valence electrons. And if you would prefer to rather write out the elements to start the structure, that's fine. So C, we know, is 4. It's in group 4 on the periodic table. So we're going to multiply that by 2, which is going to be 8. And then hydrogen is in group 1, so we're going to multiply that by 5, and we'll get 5. Oxygen, group 6, so that'll just be 6 because there's only one of them. And same with this extra hydrogen, it's going to just be 1. So then the total of all of those is going to be 20. And to get the pairs, we will divide by 2, and that will give us 10. So we're going to be making 10 pairs in our structure. So now, to start it, we have 2 carbons. So we have 1, 2. Okay? And now we have 1 oxygen, so we'll put that right next to the carbon. Now we have to, using the rule 3, we're going to put pairs in between the combining elements or atoms. So there's a single bond in between each. Now we have to fill in the hydrogens. So there's 5 here and there's 1 here. So we'll do 6. So hydrogen, hydrogen, hydrogen. And then we're going to put it out here just to make it easier. So now we're going to put more single pairs and try to get 10 of them. So we'll put a single pair right there, single bond, okay, and these are all single bonds because they're not by themselves, they're combining 2 atoms. Oh, and we'll put some around the oxygen, I believe. And let's count and just make sure there's 10 pairs. 1, 2, 3, 4, 6, 7, 8, 9, 10. And this is your Lewis dot structure for ethanol. Pretty sure that's it. And yeah. Okay. I'll just redo it again. Just